Okay, we're looking at 6.2.6, and it says we have P of 0.18 and N is 83. And so what we need to do is first find the mean and the standard deviation. Remember, when you have N and P, to find the mean, you will do N times P. But let's go ahead and say N is 83, P is 0.18. So Q has to be 0.82 because P and Q have to add up to 1. So to do the mean, you will take N times P. So if you do 83 times 0.18, you will get 14.94. And then to find the standard deviation, you do N times P times Q, and you take the square root. So if you multiply those three numbers together and take the square root, you get 3.5. Now for B, what is the probability of exactly 10 successes? Now, we have to use intervals when we're doing the NP-Q type problem. So what we need to do is do an interval here. We need to do, let's see, we need to do the interval of 9.5, 0.5 above and 0.5 below, 9.5 and 10.5, okay? And then we're going to do 9.5 minus our mean, which is 14.94, divided by 3.5, and 10.5 minus 14.94 divided by 3.5. So if you do both of those, let's see what I got on this one. I think I got negative 1.55 here, and I got negative 1.27 here. So you have to look on your table and get your z-score. So the z-score for the bottom one is 0.0606 and then 0.1020. Remember, when we're doing this, if we have an interval, let's say between 9.5 and 10.5, we want the area in between. Well, when you look up the z-score for 10.5, you get the area of all this. So you take that number, which is 0.1020, and we want to subtract out this area here because we do not want it. We want just the area from here to here. So subtract out the area under 9.5, which we looked up and got 0.0606. So if you subtract 0.1020 minus 0.0606, you will get your answer 0.0414. Okay, so now let's look at the next one. The next one is the probability of 9 to 16 successes. You kind of work it the same way. We have to do, we can't stop, if we want it to include 9, we're going to go bump back 0.5, so we're going to do 8.5. And then if we want it to include 16, we're going to add 0.5 to it, so our interval is 8.5 to 16.5. And then you subtract like you did a minute ago and divide by 3.5 and get those numbers, and then look up your z-scores. So you get negative 1.70 here and 0.3 here, I believe. And then let me check and make sure that's right, because this is the part the first time I did it, I forgot to bump it back some to include the 9. You have to bump it back. So this is going to be negative 1.84. And then on the second one, this is going to be, I believe, 0.45. So if you look those up on your, this is why I missed it the first time. So let's look these up real quick. Negative 1.84 0.4 and 0.45. If you look those up and subtract it, you should get 0.6392. Okay. Same thing here. You're going to use 6.5 and 12.5 and subtract them and divide by 3.5. Look them up. Get your z-scores and subtract. I'm going to keep going just for time purposes. Okay, so moving on. Question number 7. Let's see if it's similar. Question number 7. Let's go on to question number 8 because they're very similar, but it asks an extra question, I think, on the bottom. What is the probability? Okay, first of all, this is one that we're going to do. I believe we're going to use technology here because we don't have tables. So these kind of get quicker to do. First of all, you do need to know, put your standard deviation. I don't really have to work anything here. What you do is you go to StatCrunch, and let me just show you how to get to it. Go to Stat, Calculators, I believe, Normal. And then you put in your mean and you put in your standard deviation. And I believe our standard mean was this. This is given to you. Let me check and make sure that that's the right problem that I'm looking at. 234.46 and 21.88. And what's the probability that the randomly selected luxury hotel rate will be less than 251? So all you have to do is put 251 in here and compute. So you get 0.7752. For the next one, more than 266, you just go in and you do more than, and you don't change the mean or the standard deviation. 0.0747 for the next one. And then what is the probability? It's between 239 and 259. So first let's look at 259. And it says between those, so it's not going to be higher than 259. So 259, it is 0.8689, or rounded up to 0.8690. Okay, but we know it is between 259 and 239. So the 239 right here, we need to find the area up under it and subtract it. So remember the number 0.8690, and let's do 239. 0.5822. So what we need to do, we don't want it from here back, so we need to take this amount and subtract it from our original amount. Remember, our original amount for the 259 and back is 0.8690. Subtract out the 0.5822, and if you do that, 0.5822, you would get 0.2868. And then for the next one, the managers want to see that daily rate at the 75th percentile. So here we're working backwards. We know the probability or the area. So if we put 0.75 in, we're looking at this number, 249.22 would be where the 75th percentile was. Okay, and then for question 9, okay, probability, same type problems here. What is the probability that a randomly selected game will be exactly 160 minutes? If you read in your textbook or you read in this example, I'm going to go right on down to part C, and theirs will be similar. Note, there's no area under the normal standard curve at a specific value. Okay, so there's not, if you pick one exact point, it's always going to be 0. Okay, and then the last one, what is the completion time at which 99% of the games will be finished? When I put .99 in, I got 285.36. Hold on. So what I have to do, what is the completion time in which 99% of the games will be finished? What I did on this one, and this is kind of crazy, but I think I went to p-value, and I could probably give you these numbers, but if you want to find the p-value real quick, I will show you a quick way to do that. Do p-value from Z-score calculator. And if you do that, and you know, let's see if I can scroll down. I'm not sure if this is the one that I use. Calculate. Let me go back. I'll have to find it and see, and I will send y'all information on how to do that, because I don't want to waste time, so I apologize for that. But I found my for the 99 percentile, the p-value associated with that was 2.32635 times 10. You have to do the mean plus the z-score times the standard deviation. So if you look right here, if you look in your example, we need to know, I had to do mine by hand and it was 0.99 because it was not coming out right. You have to use mean plus z times the standard deviation. So I'm going to try to look one more time and see if I can get it to come up. Let's see if it will do it this way. Z-score. Okay, I can't find it on here, but I will look some more and get that to y'all so you don't know how to do that. I hate to end on a bad note, but that's really the only problem you may have trouble with. But if it's a 99%, the p-value, the z-score will be 2.32635. So I did the mean, which was the mean was 163 minutes plus 2.32635 times the standard deviation, which was 10.